Hi everybody, and today we're going to be working on a motion sensor connected to a solar panel. Here's the first thing you're going to need. You're going to need a motion sensor. You're going to need 8 LED lights. You're going to need 9 120 ohm resistors. And you're also going to need a BD139 transistor. Now, the way this is going to be set up is you're going to connect the negative of the BD139 transistor to the negative on the motion sensor, and then you're going to take the out of the motion sensor and connect it to the out on the BD139, which is going to be connected to a 120 ohm resistor. The other line in the center of your transistor, let me just pull this up real quick. The middle one, you're going to connect that to the negative side of all of your LEDs, which is the yellow wires right there. So they're all going to be connected in parallel, and then the last wire that you have left over is going to be connected to the blue on your transistor, and then the red, your positive, is going to be connected to the positive on the motion sensor, which is going to connect all of your LEDs positive side together. So that's the white ones. Those are all connected to a 120 ohm resistor, and then at the very end they're going to connect to the positive, which is all going to be connected up to a battery pack. Now here's the thing: the battery pack will operate this, but it tends to drain the batteries. You can adjust this motion sensor. You can see that there actually is two adjustments. One is for distance and one is for time frame. So I have this down to about 15-20 seconds for the time that it's on, and I have it set for about 7 meters. And then what I did was I connected the solar panel to this. Now you can see that there is wires running off of the back of this right here. The positive has got a blocking diode in it to prevent any charge back into the solar panel. When you put the blocking diode in, you want to make sure that the positive side is going towards the solar panel and is connected to your positive wire, the red one right here, and that the negative's connected towards the battery of the blocking diode. So this prevents any charge back going into the solar panel. Then what I did was I turned this block right here. I actually drilled a hole in the back, and I cut a slant at it to put this solar panel at an angle. So when you look at this from the angle that I have, you can see that the solar panel is plugged into this block and is connected with these magnets right here that are on this metal plate and on the block of wood. And then I put a little sealer. Let me see if I can open this up a little more here. I put a little sealer on the top right here and a little sealer. So there's sealer right down through the side right here. And it's just sitting there. It's not connected to anything. And then I put a little sealer right here to prevent any water drip down so it doesn't go into this outlet right here. And then all I have to do is just simply plug this into the back side, and it would power this solar panel. The solar panel is powered by the sun, and then when the sun is out, it'll run if the batteries get drained, it'll charge the batteries back up, and at nighttime the batteries will not back charge into the solar panel to charge the solar panel back up. So that's a good side. And then on top of this, this solar panel you don't need direct sunlight for it. So I can actually operate it on these LED lights right here, and it would still run a charge on the solar panel. So when I set it up outside, it'll actually set up at an angle, as you can see right here. So it's angled at the sun, but at the same time it doesn't need direct sunlight on this. This is a great unique idea. Just keep in mind that when you're putting the blocking diode in, you put it in the right direction. If you have any questions on this motion sensor or the solar panel connection, please feel free to leave me a message and I will get back to you as soon as possible. Thank you.